Hello, I'm glad you are here. Today we are going to explore how plasma and sputtering process work. You have just arrived in the right moment. Take a look. I've prepared something special inside this vacuum chamber. I have a metal plate here made of copper. I've connected it via cable to the generator. Now I'm closing the chamber and creating a vacuum. If I now switch on the generator and apply a voltage to the copper plate, we can ignite a plasma. A plasma containing copper glows in a beautiful green light. Besides glowing so beautiful, the plasma atomizes the surface of the copper plate. If I bring my substrate close to it, the atomized copper deposits as a thin layer on the substrate, just like on this small plate over here. This whole process is called sputtering. Let's take a closer look at what's happening there. Let's start again with this copper plate. We refer to it as a target. As I just shown, we connect the target to the generator. Specifically, the negative pole of the generator is connected to the target. The other positive pole is connected to the anode. We simply use the vacuum chamber as an anode. And now, when I switch on the generator, an electrical field is created between the anode and the target. You probably know that an electric field can influence charge carriers, like this small electron over here. The electron is negatively charged and is therefore accelerated towards the positive pole of the electric field. For the sputtering effect, we need some gas. We like to use argon as a process gas. If argon is present in the space where the electron is flying, a collision will occur sooner or later. If the incoming electron has gathered enough energy, it can knock out an electron out of the argon. And then two things happen. We now have two electrons, one that came flying in and the other one from the argon. And these two are now accelerating again towards the anode and can continue to collide. And secondly, the argon atom has now become a charged ion. It is missing one negative charge. Therefore, the argon is positively charged, and charged carriers are influenced by the electric field. In this case, the positive argon is accelerated towards the negative target. If it hits there, it can knock individual target particles out of the copper plate. And this is what we call the sputtering effect. Now I just need to bring my substrate close to the target, and the target particles will deposit as a thin layer on the substrate. And the light? Well, depending on the gas and the target material used, light of different wavelengths is produced. A copper target in an argon atmosphere glows green. If silicon is sputtered with an addition of nitrogen, the plasma glows from pink to rose. Light is produced when an incoming electron doesn't have enough energy to completely knock out an electron out of the atom, but has enough energy to excite an electron within this atom. If this excited electron falls back to its original position in the atom, it releases energy again, and this energy is in the visible range of the spectrum. So, that's enough for today. Now you know that in sputtering we create an electric field between the target and the anode to accelerate electrons. These electrons can knock out other electrons out of the atom, thereby turning these atoms into ions. The positively charged ions accelerate towards the target and knock particles out there, which we settle on the substrate. As a byproduct, the light is produced. Next time, I will tell you why all of this is called magnetron sputtering and what the magnetic field has to do with it. You definitely have to see what happens next.